design of digital controller using Kalman's controller. Let us design controller for 3 cases. One is for 1 upon 3s plus 1. Second one is e power minus 1.346 s upon 3s plus 1. First order plus dead time. Third one is 1 upon s plus 1 to the power 4. First, let us design for the first case. For that, before going for that, what is the assumption made in while designing? At t equal to 2, the output is equal to set point. PV equal to set point from second sampling period. At first sampling period, at t equal to 1, the input is given at t equal to 0. Let us assume that it is C1. The output is magnitude of the output is C1 at first sampling period. From second sampling period onwards, the output is equal to 1 for a set point change. Unit step set point change. That is R of S equal to 1 by S. R of S equal to 1 by S, or R of Z equal to 1 upon 1 minus Z power minus 1. For that input, so R of S for a given step input. This is the step input given. For that, this is the response. This is the response. That is the assumption we made. What is C of Z? The response is C of S. What is C of Z? C of Z is at the first sampling instant, the output is C1. Therefore, we can write C1 Z power minus 1. We can write plus, what is the magnitude of second sampling period? 1 multiplied by Z power minus 2 plus Z power minus 3, Z power minus 4. Magnitude is 1, etc. This is the output, the response for a given step input. What is R of Z? R of Z equal to 1 upon 1 minus Z power minus 1. What is the closed loop transfer function? That is C of Z upon R of Z. That is required to find D of Z, because D of Z equal to 1 by HGP of Z. The numerator C of Z upon R of Z divided by 1 minus C of Z R of Z. That is the formula that we know. That is D of Z equal to 1 by HGP of Z, C of Z upon R of Z, 1 minus C of Z upon R of Z. Therefore, C of Z upon R of Z equal to, if you divide by this, what you will get is 1 minus Z power minus 1 multiplied by C1 Z power minus 1 plus Z power minus 2 plus etc. This can be written as C1 Z power minus 1 plus Z power minus 2 plus Z power minus 3 plus etc. minus C1 z power minus 2, z power minus 3 plus etc. If you subtract this from z power minus 3 onwards getting cancelled. Therefore, C1 z power minus 1 plus 1 minus C1 z power minus 2. This is C of z upon R of z. C of z upon R of z. Let us call this C of z by R of z equal to P of z. Therefore, P of z equal to this. Let us assume that P1 equal to C1 and P2 equal to 1 minus C1. Therefore, P1 plus P2 equal to 1. If you add these two, C1 getting cancelled and P of z equal P1 plus P2 equal to 1. So we can call C of z by R of z equal to P of z when P1 plus P2 equal to 1. Then only it is the given assumption is true. What is controller output? The controller output M of z equal to at initially it is M0, then it is M1 z power minus 1 plus MF z power minus 2 plus MF z power minus 3. Why MF constant? After that, the process is settled. That's why control output also settled at one value. That's why MF final value of controller, MF plus etc. What is HGP of Z? HGP of Z equal to, in a closed loop transfer function, what is the input to the process? That is HGP of Z, M of Z. What is the output of the process? C of Z. C of Z by M of Z. HGP of Z equal to C of Z by M of Z. Or we can call this as C of Z upon R of Z whole divided by M of Z upon R of Z. That is equal to what is before that let us write one more step for this. What is M of Z by R of Z equal to what? R of Z equal to 1 minus Z power minus 1. Therefore, if we divide this polynomial by 1 by 1 minus Z power minus 1, M of Z by R of Z equal to 1 minus Z power minus 1 multiplied by M0 plus M1 plus MF Z power minus 2 plus etc. Let it be Q of Z. M of Z by R of Z is Q of Z. C of Z by R of Z is P of Z. C of Z by R of Z is P of Z. Already we derived. C of Z by R of Z by, for the given assumption, we got P of Z. Therefore, HGP of Z can be written as P of Z upon Q of Z. When we can call the numerator as P of Z, what is the condition for P of Z is P1 plus coefficients, P1 plus P2 equal to 1. Then only it is P of Z. That is already we have seen here. If you add the coefficients of P1 and P2, coefficients of P, you will get 1. If you add coefficients of, we know that C of Z by R of Z is P of Z. When we can call it as P of Z, if you add the coefficients, it must be 1. What is Q of Z? That is M of Z by R of Z. That is Q of Z. M of Z is M0 plus M1 Z power minus 1 plus MF. It reaches final value. Why? Because the process is settled. M of Z by R of Z is this. Let us assume that this is equal to Q of Z. But HGP of Z equal to what? C of Z by M of Z. In a closed loop system, we are giving set point is here. After that, the controller is there. After that, a hold circuit is there. Then the process is there. This is HGP of Z. A sampler is there in between. Here output is C of Z. Here the input is M of Z. Therefore, HGP of Z equal to C of Z by M of Z. That is controller. This is controller output. Controller output. This is output of the process. Output of process. That is HGP of Z. But C of Z by M of Z can also be written as C of Z upon R of Z divided by M of Z upon R of Z. But this is equal to P of Z. We substituted here. This is equal to Q of Z. For Kalman's controller conditions, this can be called as P of Z if P1 plus P2 equal to 1. Therefore, what is the controller? D of Z equal to 1 upon HGP of Z, C of Z upon R of Z, whole divided by 1 minus C of Z upon R of Z. C of Z by R of Z is P of Z. 1 by HGP of Z. What is HGP of Z? P of Z by Q of Z. Therefore, we can write 1 by HGP of Z can be written as Q of Z by P of Z multiplied by C of Z by R of Z is P of Z upon 1 minus P of Z. P of Z getting cancelled. Therefore, D of Z equal to Q of Z upon 1 minus P of Z. That's all. The controller is nothing but Q of Z upon 1 minus P of Z. That is Kalman's controller. What is P and Q? P and Q is nothing but HGP of Z. If you find HGP of Z, then the HGP of Z numerator coefficient, sum of numerator coefficients equal to 1, then it is P of Z. Whatever in the denominator is Q of Z. Whatever in the denominator is Q of Z. Immediately we can write the controller. D of Z equal to Q of Z upon 1 minus P of Z. That is only one condition. That is P of Z should have the sum of coefficients equal to 1. That's all.